Hello, welcome to video 2H. This is about limits and complex fractions. This is Mr. Miller here. We're going to do 4 examples. There's a lot of algebra in these problems, so I hope through 4 examples you can see what's going on and then do 2 examples of your own. Here we go. This is our first example. A complex fraction is an expression that has fractions in the numerator and in the denominator. So here the main dividing bar is right here, this thicker black line. And we see that the numerator has the fractions 1/4 plus 1 over x. In order to simplify this limit, we have to do something about those fractions. And the technique I'm showing you is multiplying through by something that would cancel them. Okay, well, it turns out since the denominators are 4 and x, if we multiply the whole numerator by the quantity 4 times x, it'll cancel those denominators, and we'll see that happening. We'll clear out the fractions. So the simplest thing to multiply by is the product of the denominators. All right. If you want, you can use the least common multiple of the denominators, and that would be even better. But if nothing else, use the product. So we're going to multiply the whole numerator by 4x, and then we have to multiply the denominator by 4x as well. So this is what we get. We get the limit as x approaches -4. I'm going to write the denominator first because that's a little easier. I'm actually not going to distribute this. My hope is that something cancels in the future. So I'm just going to copy the denominator. I wrote it as x plus 4 instead of 4 plus x. There's no reason, but they're equivalent. All right, now I got to do 4x times 1/4. So I'm going to write out all the steps here. So that's 1/4 times 4x, then plus. When we continue the distributing here, we have 4x times 1 over x. So 1 over x times 4x. So we're multiplying by a common denominator, and we have to distribute it. Now, let's keep going. We still have the limit, so I need to keep writing that until I actually evaluate it. Limit as x approaches -4. Here, when we multiply 1/4 times 4x, the 4's cancel because we're dividing by 4 and multiplying by 4. 4 over 4 is 1. Okay, and we're left with 1 times x, which is just x. So that's how the first expression simplified. Here I have 1 over x times 4x. This time the x is canceled because I'm dividing and multiplying by x. Again, because it's x over x, which is 1. And I'm left with 1 times 4, which is 4. Okay, so the numerator simplified dramatically. And the denominator, I'm just going to copy the same thing. Now remember, my hope was that something somewhere would cancel. And we're going to see it is. Both the numerator and the denominator have a factor of x plus 4. Here it is in the denominator in parentheses, and in the numerator, there it is. We can think of this as x plus 4 times 1. When I cancel out x plus 4's, there'll be 1 left in the numerator. Okay, so here we go. Limit x approaches -4. I'm going to cancel those, and I'm left with 1 in the numerator, and in the denominator, we simply have 4x. Okay, now I'm actually in the position to take the limit. Over here, we were in trouble. If I substituted -4 in, we would have had 0 here and 0 there. But now when I substitute -4, there's no problem. The numerator is 1, and the denominator is approaching -16. So this limit is exactly that, 1 over -16. Usually we write the negative out front or on the numerator, so this is -1/16. That's the limit. Okay, at -4, it's actually undefined. This huge mess would have a hole in the graph there if we graphed it, but the limit as x approaches -4 is -16. Okay, now, next problem. Same trick. We're going to multiply by a denominator that would cancel the fractions. So, here we go. I'm just going to multiply the 2 denominators we have. And I'm going to multiply everything times the quantity 5 times x plus 2. And in the denominator, 5 times x plus 2. Okay, let's see what we get. We get the limit as x approaches 3. And I know I'm going to need a big division bar. And in the bottom, we have quantity x minus 3 times that. So I'm going to write the 5 first. It doesn't matter the order of the other factors. X minus 2 times x minus 3. Again, I'm not multiplying that out because I am predicting something's going to cancel. It better in order for us to do this. All right, up here, I'm going to kind of write it, show all my work. We're going to have 2/5 times 5 times x plus 2. We have a minus sign here, so minus this fraction, 2 over x plus 2 times 5 times x plus 2. All right, this is what's fun about calculus. It's intense. A lot of algebra. Okay, but hopefully the steps of what we're doing are easy to understand. There's a lot of details here, but all I did is multiply the numerator and denominator by some quantity, and I just distributed it. Now I'm just going to cancel factors. Here, a 5 and a 5 will cancel. And I'm left with 2 times that. I'm going to save us a little time by just going ahead and distributing that. 2x plus 4. I know that whatever I get here, I'm hoping to combine with whatever I get there. All right, over here, x plus 2 will cancel this x plus 2. And we're left with minus 2 times 5, which is minus 10. And then over the same denominator, 5 times x plus 2 times x minus 3. It's getting somewhere, all right? So this is the limit as x approaches 3. We have 2x minus 6 over 5 times x plus 2 times x minus 3. Now, you might be a little disappointed. You might say, Mr. Miller, I was hoping something would cancel. It will. We just have to factor the numerator. We can factor out a 2, the greatest common factor there. So this is the limit as x approaches 3 of 2 times x minus 3 all over 5 times x plus 2 times x minus 3, and there it is. How about that? That's gone. Okay, I'm going to save us a little writing. We can go ahead and take the limit now. As x approaches 3, the numerator is 2, and the denominator would be 5 times 5, since 3 plus 2 is 5. So after all our work, we get 2 over 25. Now, there are a lot of steps here. So this is why I assign odd problems in the book. When you're doing a problem from the book, check your answers. If you get something else, you got to go back and think. Okay, what did I go wrong? It could have easily been just a little negative sign, or I didn't cancel something. But that's how you learn. So you go back, you figure out what's wrong, and you practice this, and you'll get really, really good at it. Okay, these are kind of intense and a lot of writing, so it's taking a little time. That's okay. We have 2 examples left. On this one, there's only one denominator I want to cancel, this x minus 2. By the way, the fractions aren't always in the numerator. Sometimes they're in the denominator. It just turns out that for these examples, it turns out that the part we have to simplify is the numerator. So I'm going to multiply by x minus 2. If you really want, you can think of the denominator here as being 1. Okay, so I'm going to multiply numerator and denominator by x minus 2. So here we go. This is going to be times x minus 2. And this is going to be times x minus 2. Okay, so we get the limit as x approaches 1. When I distribute, okay, I'll keep writing it out until we're really, really good at this. X minus 2. Sometimes I want to skip some steps, but I want you to see what's going on. Plus 1 times x minus 2 all over x minus 1 times x minus 2. Okay, what did I do? I just distributed this. I multiplied this times the first quantity, then I multiplied it times the second quantity. All right, here we go. These cancel. They leave me with 1. So we have the limit as x approaches 1 of 1 plus 1 times that is just going to be x minus 2 all over x minus 1 times x minus 2. Okay, things are happening. 1 minus 2 is negative 1, so this is the limit as x approaches 1 of x minus 1 over x minus 1 times x minus 2. Okay, now x minus 1 is a factor of the numerator and denominator. Remember, I can think of this as x minus 1 times 1. We can only cancel factors. So there we go. And we're left with the limit as x approaches 1, I lost my 1 there, of 1 over x minus 2. If we substitute 1, the denominator is going to be negative 1. So we get 1 over negative 1, which is negative 1. Crazy. We can do this. All right, we made it to the last example. Okay, this is kind of previewing what's coming in the next chapter. We did problems like this, but they didn't have a fraction like this, a rational expression. So this is called the difference quotient. It's the difference between the values of the function at two different points divided by how much x changed. So we added h to x, and we found the difference between the function there and the function at x divided by how much x changed. More about this later. But our job now is just to figure out what this expression is using this function and do the limit. So here we go. The limit as h approaches 0. All right, f of x plus h. We got to substitute x plus h into the function. So this would be 1 over x plus h. Okay. Minus f of x, that's just 1 over x, all divided by h. All right, so the problem is when h goes to 0, this is 1 over x, that's 1 over x. When you subtract them, you get 0, and the denominator is going to 0. So we know that's trouble. When the limit's approaching 0 over 0, we have to do something. Okay, well, easiest thing to do is get rid of the denominators here. So we're going to multiply by x times x plus h. I just multiply the two denominators and I get a common denominator. And I have to multiply this down here by the same thing. So times x plus h. So we get the limit as h approaches 0. The denominator is easy because I'm just copying it. I get hx times x plus h. I got three factors. An h, an x, and an x plus h. In the numerator, let me write out what we get. We get 1 over x plus h times x plus h minus, now I'm going to do this one, 1 over x times x plus h. All right, sweet. These will cancel here. The x's will cancel here. Let's see what's left. So the limit as h approaches 0, here we just have x times 1. We have minus, what's left here? Well, the x is canceled there, and I'm left with minus 1 times x plus h, so it's just minus x plus h, over x plus h. All right, we keep going till we can't simplify anything. As the limit as h approaches 0 of, well, x minus x will be 0. We're left with minus h over h times x plus h. We're still in trouble because this goes to 0 and that goes to 0, but these cancel. And we're left with the limit as h approaches 0 of minus 1 over x times x plus h. And now we can do this. As h goes to 0, x plus h becomes x. This part's going away. So we have minus 1 over x times the x, which is minus 1 over x squared. Ta-da! We did it. So remember, as we're doing this, as h goes to 0, we treat x just like a constant. All right, so we're done here. We got something involving x. That's not a big surprise. So x just kind of was carried through this whole thing. Whatever number it is, if you want x to be 2, then I guess this is negative 1 over 2 squared, which is negative 1/4. This is actually a formula for the derivative of this function. That's coming next week. Okay. Wow, those are 4 really big examples with a lot of algebra. The way to study calculus is maybe write down the problem, see if you can work through it yourself. And if you get the same thing we did, you're doing good. If not, go back, see what happened. All right, time for the journal assignment. I have 2 for you that kind of match the examples we did. All right, so I'll take a few minutes, work these out carefully, and we'll see you next time.